Hey guys, welcome to the final day of parent functions. Today we're going to talk about cube and square roots. And so what I want you to do with your partners is create the following functions on one coordinate plane using different colored rubber bands. I've given you the parent function. This is the cube root of x. So I really would like you to use negative a, negative 1, 0, 1, and 8 for all of these. And then you can discuss the transformations that happen to the original function. By this point, the fourth day, this should be very simple for you. And a lot of the things that I'm going to say, you should already know what is going to come out of my mouth before you hear it on the videotape. So go ahead and stop this. And then when you're ready, let's move on. All right. So this equation is the cube root function. Boy, try to say that 3 times, right? And the parent function is the function at x is equal to the cube root, and remember we put the index there, of x, okay? And then again, this is called a cube root. Now, ladies and gentlemen, because it's a cube root, the domain, of course, can include all positive and negative numbers, okay? And the range will also include all positive and negative numbers. And what did you notice when you graphed this? Well, what you should have noticed was that it almost looked like the what? Yeah, it looked like you took the cubic function and you just kind of laid it on its side, didn't it? Okay, and so what you would see is that the y and the x-intercept are both at the same place, correct? Another thing that you should have seen is that you had symmetry around the origin. And since you have symmetry around the origin, that means that this is, of course, an odd function. Now, is it one-to-one function? That means for every x, do you have a unique y? And for every y, do you have a unique x? And the answer is, of course, yes. Okay? And that is because every coordinate pair is unique. Okay? All right, so what about increasing and decreasing and over what interval? Well, if you notice with this parent function, if I were to draw a linear function that kind of mimicked this, I would notice that even though it's kind of shallow, it is increasing. So this is an increasing function. And the interval, of course, is, that's right, the full domain from negative infinity all the way to positive infinity. Great. All right, so what happens if A is negated? Go ahead and put this information into your graphing calculator. Now I want you to take a real close look to how Mrs. Rose puts the cube root in. With exponentials, and we may have not been able to discuss this before, and you may not have heard it last year, but the cube root can be written as raised to the power of 1 divided by 3. That means that you are using x as a factor 1 time in the radicand, and you are taking the cube root. Don't forget that this negative sign is the negative sign, not the minus sign. Of course, I hope you remember how to get to the graphing screen. So once you get this done, if you need to pause the videotape, pause the videotape. Okay, now that you've come back, hit zoom 6, and hopefully you'll see something that looks like this. Notice that it reflected across the x-axis, and that is what I expect you to write right here. And then I also expect you to graph this in your parent function book. All right? Sounds good. Pause the videotape and get that done. All right. What if A is greater than 1 and A is, the absolute value of A is between 0 and 1? Let's go ahead and pause the video and put this information in. All right. Welcome back. Hit zoom 6. And this is what you should get. Notice what happened. That's right. This is a vertical stretch towards the y, and this is a vertical shrink towards the x. Let's make sure we write our information in here, and we also graph in our parent book. Go ahead and pause the video so you can get things done. Welcome back. What about the vertical shift? Go ahead and put this information into your graphing calculator. Pause the video. Good. Are you back? Did you make sure that you put these parentheses where they should be? Did you also make sure that you changed the view so that you would have different types of lines? Good. Go ahead and hit Zoom 6, and hopefully this is what you'll see. So, what are you going to write here? Have you noticed the pattern for every single parent graph that we've done as far as vertical shift goes? What happens if you see a plus K? What happens if you see a minus K? And of course, pause the video so that you can answer those questions and graph. Welcome back. What happens with the horizontal shift? Here you go. Make sure that you have your parentheses exactly where you need it to be. Go ahead and pause the video. Welcome back. Did you hit Zoom 6 already without me? Well, if you did, this is what you saw. Now, it is very hard to see a captured screenshot. So hopefully you went ahead and wrote down as this was happening and as this was happening, what happened with each of those, and also make sure you pause to graph. So, in your important notes, notice that we now have the function at x is equal to a times the cubed root of the radicand of x minus h, and all of that has a plus k. Notice that the plus k is not inside the radicand. I'll bet you already know what you're going to have to write here, but just in case you've forgotten, a negative a reflects over the x-axis. Absolute value of a greater than 1, vertical stretch towards the, that's right, y-axis. Between 0 and 1, and oh my goodness, I'll bet you Colby's going to say to me, Mrs. Rose, didn't you mean to write an A there? Yes, I did, Colby. That's a vertical shrink. Opposite of H, horizontal shift to the right. Positive H, horizontal shift to the left. Positive K, vertical shift up. Negative K, vertical shift down. All right? So far, so good? Great. Well, go ahead and pause the video if you need to. All right. Square root functions now. Working with your partners, create the following function on one coordinate plane. Okay? Go ahead and pause the video. Hey, welcome back. This, of course, is f of x is equal to the square root of x. This, of course, is called the square root function. All right, there's a problem with our domain, isn't there? It can be equal to 0 and go to positive infinity. Why don't you talk to your partners and please tell me, why, oh why, can I not have a negative number? Okay, what about the range? The range will also look like this. The y-intercept, the x-intercept. Now, hopefully when you did this, you noticed something very special. You notice that this only has what? One branch, kind of like it's an eyebrow, isn't it? So there is no symmetry, and of course it's neither, but it is one-to-one because all of the points are unique. Whoops, unique with a Q. And of course this one is increasing across the domain of 0 infinity. All right, what happens if A is negated? Notice that we talked about this earlier. Let's go ahead and put square roots in as raised to the power of 1/2. Stop the video. And you know what to do after this. Don't forget, you're going to have to pause the video to graph and to write what happens. And hopefully yours also looks like this. Okay, what about if we change A? Go ahead, pause the video, but make sure that you graph and write the information that you need to. And hopefully yours looks like this. Notice that it stretches and then that's right, shrinks. What about a vertical shift? Well, let's go ahead and put this information in. Pause the video after you make sure that your parentheses are in the right place. And then hopefully you have all of this information on your parent function book. Okay, horizontal shift. Graph, right, and that's right, check to make sure we match. All right, so f of x is equal to a square root of x minus h plus k. I'm sure you know what this is going to say. Up. There we go. Make sure that you pause that whenever you need it. I will tell you that this is one of my favorite websites, so why don't you go ahead and pause the video and check this website out, okay? All right, so time to practice with a partner. Create a cube root or square root function and see if your partner can write the new equation. This is going to be very important for tomorrow because tomorrow's classwork assignment is going to be turned into Miss Jones for a grade. You are going to use your parent functions and you're going to do some classwork with stretches, shrinks, and shifts and writing new equations. There will be no video tomorrow. Have a great green and gold day. I can't wait to see you guys on Monday.